So a ratio, well, let's just look back, okay? If I said I had a half, right? That's just a straight up fraction. Once we get into ratios, usually there's some kind of label with these. So I wouldn't just say I'm comparing 1 with 2. Now we are comparing two different things, usually different. Sometimes they're the same, but in actuality they end up being different. And this is the part about math that makes it kind of confusing. I may say $1, not dollars, something like a pound. 1 pound compared to 2 pounds, right? Well, 1 pound of what to 2 pounds of what? Now, yeah, it could be 1 pound of bacon to 2 pounds of bacon, depending on how we're comparing it. Is that getting more confusing or less confusing? Hey, welcome. Is that garbage? Okay. So, let's look at this. This is a fraction, and fractions, usually we can turn into decimals, right? Now, a ratio, usually we may compare this 1 to 2 of something, okay? So maybe I have 1 pie for 2 people, like this, right? So that's comparing two full values that are different, that have different labels with them.
Kind of be like mixing chemicals.
Yeah. So when you guys get into chemistry, this is kind of a big deal, right, actually. Now the 1/2, I can compare that with just one thing. So I could just say, you know what, I can just have half a pie, right? Now, if I eat half a pie and I wanted to feed 2 people, how many pies do I need? Just one. You see how we changed that from being a fraction into a ratio right there? I mean, they are essentially the same value, but we're kind of looking at them in different contexts right there. All right, rates. This also is a rate. Ratios are rates. They're pretty much the same thing. 1 pie for 2 people is a rate, okay? Now we'll get into more specifics about specific types of rates, but for now that's really all we need. And the nice thing about this is for 5.2 we'll get into proportions and why maybe we need more of this ratio kind of stuff. So ratios, by the way, are, like we saw with the fractions, it's division. So I mean you could say that you have a ratio of 2 things with division, right? Like 3 to 10, something like that. But sometimes they just, see how they just kind of took that line out of the division sign? And now we got a colon, right? So this could say, again, 3 to 10. Some people really hate all the symbolism of all this stuff. So they would say, right, they like to write, I don't know, maybe you're English major, and they just like to write the word out. So 3 to 10. All of this, it's all the same stuff. It all means the same thing. I mean, yeah, again, we can look at the fraction as well. These are all the same, and they're all ratios, okay? Now, again, we should have some kind of labels with these for ratios, which is what this stuff is. So number 1, 6 pounds to 15 ounces. Write each ratio as a fraction. So again, I can replace that word 2 with the divide right there. So this would be 6 divided by 15. But then it says to simplify if possible, right? So, well, 15 is not even. So what could I simplify that with? There we go. How do we know it's divisible by 3? Okay, well, yeah, 15 is an easy one. 1 plus 5 as well is 6, which is also divisible by 3. So let's simplify this by dividing both of these by 3. 6 divided by 3 is 2. 15 divided by 3 is 5. All right. One last thing on this, okay? Well, we were comparing pounds to pounds. And this is a word problem, so we should label these pounds and pounds. And if by chance you labeled that with this as, because they didn't specify what kind of pounds, right? That's pounds in, I think that's British stuff, right? You guys don't want to hear about the British stuff because we're in America, and that's fine too. He likes basketball. He's going to make 24 free throws out of 32, which is That's better than I can do, so. So, once again, it's, the wording on this one is a little bit different. I didn't use the word two. It's not 24 free throws to 32 attempts. But, again, we can kind of replace that with division right there. So, we really have 24 free throws to, and again, that's division, 32 attempts. Well, both of these are even, but is there another number? Is there another number that we could divide both of these by? 8. It looks pretty good right there, right? So let's divide both these by 8. And 24 divided by 8 would give us 3 free throws, compared to 32 divided by 8, 4 attempts. And that would be fully simplified right there. 3 and 1/12 to 3 and 5/6. Good. So changing these into improper fractions. 3 times 12 is 36. Plus the 1, I got 37/12. And then this one, 3 times 6 is 18. Yeah. Plus the 5, 23/6. So this is all divided, but we don't actually divide the fractions, right? So we'll change it to multiplication. Change this to multiplication. But what do? Yeah, flip of the second one. Very good. So the divisor there will flip 6/23. And then our dividend here stays the same. So we do have different ways to do it at this point, but what do you guys want me to do then?
Simplify 12 and 6.
All right. We'll cross simplify. 12 and 6. So we're dividing those by 6. So that becomes a 1. Here we have a 2. Is that okay? And now we can just multiply straight across. That's what it looks like. If not, then we'll simplify anyways later on. 37 times 1 is 37. 2 times 23, bam, 46. I can't think of anything that those would be simplified by. So it looks like that would be our answer. A tax rate of 3% to 6.85%. So again, once again, we'll just change this to division, and we have 3% compared to 6.85%. So this one is it does have that decimal, right? So, well, I don't have my calculator with me, so I'm going to have to use long division. 3 divided by 6.85. You guys remember what we did? Yeah, I've got to move that decimal, right? So when I do that, I'm going to move this decimal twice here. And this would be 3. I got to move it twice there, right? So I have 685 divided by 300 now. Well, 685 won't go into 300 either. So let's make this, going to need a chart for this one. I'll have to pull that up. All right. Well, 685 will not go into 300, but it will go into 3,000. So again, I'm just lining up the decimals there. Looks like it will go into 3,000 4 times. And so with my list there, I can see that 2740 is the next smallest number from 3,000. And when I subtract 0, carry the 1, carry from the 3, 260. And that one, looks like that'll be 3 right there. So I'm going to need another 0. 2,600. This one is the 3. So I'm going to subtract 2055. And again, carrying 9, and I'll need to borrow there as well. 5455. Looks like I may need some more numbers there. Now it did tell us in the beginning there to round to the nearest hundredth. So I really only need one decimal place just so I know where to round to. Now some of you actually wouldn't need that because we can see that 4110 puts us over halfway, but let's just see what it is anyways. So the next one I got is 4795, 5480. So that is that's too high. So 1, 2, 3, 4, 5, 6, 7. No, that's not where it goes. 7. All right. So what would we round this decimal to for the hundredths?
What are we rounding to?
To the hundredths? 2 decimal places.
44.
There we go. 0.44 is our final answer. Now that did get a little sloppy. From the chart shown on the right, find the ratio of spending on Medicare to spending on debt interest. All right. Yeah, very good. So Medicare there is at 700 billions of dollars. That's a big number. And debt there is at 200. And it told us that it wanted Medicare to spending, so Medicare is at 700 to the spending, which is at 200. So if we wrote this as a fraction, we should get 700 over 200. Now the nice thing about this one is when we're dividing by numbers with, hundreds or tens, we can just cross these out and we have 7 over 2, right? But, so 30 cookies for 8 peoples. Yeah, let's look. So again, it's 30 cookies for 8 people, so we can just divide these. And that would give us these 30 cookies for 8 people. And what would we divide these by to simplify? 2 sounds good. At least 2 because they're both even, right? So 30 divided by 2 is 15, so 15 cookies. And that would be 8 divided by 2. Gives us 4 people. Now, if we wanted to find maybe some kind of average for this, we could keep going, right? And that's what the unit rate stuff will do sometimes, okay? But at this point, this is about as far as we can take that. If this was just a fraction, that's as far as we could go. I mean, if we wanted to change it into a mixed number, that's fine. But I like the improper fraction like this, okay? This one may be a little bit more familiar. 260 miles in 4 hours. Why should this be familiar, by the way? Oh, we're driving all the time, right?
Figuring out miles per hour.
Yeah, miles per hour is really kind of what we're looking for here. So let's look. We got 260 miles. And this will be in, so that's where we'll divide by the 4 hours. And if I wanted to simplify this, yes, I can see that at least we can divide by 2, right? So let's divide both these by 2 first. Now, yeah, some of you can notice we can divide both these by 4, but not everyone may notice that. At least they're even, so we can divide by 2. So that should give us 130 miles in the 2 hours. But again, we have even numbers, so we could divide these both by 2. And we'd get 65 miles per hour. So this is a rate, and it's also a ratio, but since we're comparing 65 miles to 1 hour, that also makes it what we call a unit rate, because one of the numbers is 1. Seems like I should have a better way to say that. One of the quantities is 1. But quantity is kind of a big word, so not a lot of people want to hear it. But yes, this would be a unit rate because one of these values is a 1. So we want this to be a unit rate, right? And we're comparing two different quantities here, but only one of them really needs to be a 1. So which one would make sense? Do we want to know how many hours for $1? Or would we want to know how many dollars for 1 hour? Now, one of those should make a little bit more sense than the other. Particularly the dollars here are kind of depending on the hours usually, right? Like if you work 8 hours, buddy, then I'll pay you $90. So for this one, since the $90 kind of depends on the hours worked usually, the one would be the hours here, okay? So science talks about this a lot. We have independent and dependent variables. And, well, the $90 should depend on the number of hours. So the hours is independent. So what this means, and it really, yeah, it kind of matters how we write this fraction in a way. It's more of a formality because here we can kind of say that this is divide, right? So we would say that we have $90 for 8 hours. But as long as we know which one we need to be 1, if you wrote this as 8 over 90, that's okay as long as you still understand that you're looking to figure out how many dollars for 1 hour, okay? It's just a little untraditional to do it that way, okay? So if I wanted 8 hours, I'm sorry, if I wanted 1 hour, but I have 8 hours, how do I change that 8 to a 1? Yeah, divide, right? So now again, this part of this is because we want this to be equivalent, and we'll get into that. We've already mentioned a little bit about proportions. So yeah, we're going to divide this by 8, but to make it equivalent, if I divide by 8 in the denominator, I have to divide by 8 in the numerator as well. So 8 divided by 8, that's 1, that's good. That's what we want. But 90 divided by 8, well, you know, we can use a calculator for that, but I got, no, not 12, 11?
11.25.
11 point, I do that wrong in my head. Let's make sure. 90 divided by 8, oh, 25, yeah, thank you. I must have been thinking of 4. $11.25 for every 1 hour. And that's a unit rate again because we're comparing one of these quantities as 1. Well, same idea for this one. $9.75 for 12 cans. Again, we're just dividing here, so $9.75 for 12 cans. Now, what do we, again, are we looking for a number of cans for $1, or are we looking for dollars for 1 can?
Dollars for 1 can.
Usually dollars for 1 can, okay? Now, I mean, it is possible to figure out how many cans for $1, but it would be really weird if you had a decimal value for a can, all right? Does that make sense, though? I mean, yeah. So grocery stores do it that way sometimes, right? They'll say how much money per can, and it's good to compare it that way, but for our context, hopefully it makes sense that we're looking for 1 can right there. So what would we do to this problem? Yeah, divide by 12, very good. So if I divide both these by 12, well, 12 divided by 12 is just 1, so I got 1 can. And how many dollars is that? 9.75 for 12, divided by 12. I got 0. Now this was 8125 right here, right? But there's not really such a thing as hundredths or thousandths of a cent. So what would we round this to? 81 cents. As far as I know, the groceries don't. They'll still round that up to 2 pretty much. But just for our purposes, we'll just round this to the hundredths. There we go. She drove her car 585 miles and used 10.8 gallons of gas What was her miles per gallon? Well, this one told us specifically the values that they want for the rate. So that means that in my fraction, I'm going to have miles in the numerator, and it's per gallon, so divided by the number of gallons. Again, the nice thing about that is it tells us specifically where to put each quantity. So 585 miles, and 10.8 gallons. Well, that's better. That's a 10. Well, we want to know how much this miles will be, specifically per gallon. Now, per gallon, how many gallons are we talking about that we want to compare the miles with? Because it's important to know this, okay? So when it says up here miles per gallon, how many gallons is that? 1, right? So that's a unit rate is what it comes out to, is 1 gallon. So again, we have to ask ourselves, how do we take 10.8 and make it a 1? There you go. Divided by 10.8, and that would give us 1, but if I do it to the denominator, then I got to do it to the numerator as well. So 585 divided by, 585 divided by 10.8, so this is what my calculator shows me right here, 54.166, and that repeats. So again, we're rounding to the nearest tenths, which is what it says right there at the top. So that 66 makes this closer to a 7 or 70. And that would be our answer right there. Per gallon, yeah, thank you. So we have this tag right here. Let's look at 15. What is the unit price for these eggs? So it shows us that there's 18 eggs right here for $2.49. So, I mean, it is per egg, which does make more sense on this one. So, yeah, let's make this per egg right here, right? So we got $2.49 for 1 egg. Dang it. I am all over the place today. I apologize. Well, let's divide this by 18 so that we can figure out how much it is for 1 egg. And 249 divided by the 18. I'll type it in the right place. 249. I got 0.1383 repeating in dollars. But again, we just want to round this to the nearest penny, so this should round up to 14 cents, or about 14 cents per egg. What is the unit price for these eggs? Writing the result as cents per egg. Well, that's 0.14, so 14 cents for 1 egg. We just have to be careful with how we do that, because a common mistake on this one is just to say, well, it's 14 cents, so we just say 14 like this, $14 per egg. But again, it's all about the label. I know the work was done right there, but the labeling is all wrong. It's not $14 per egg, it's 14 cents. So just be careful on that. You notice the following labels while buying tissue. The first picture is for a 3-pack box of name brand tissues. So this is, I guess it didn't say there, what the heck. So there's a 3-pack. And the second is for a single generic box. So this is, if you want to write it as a 1-pack, that's fine. Can you trust the labeling for the unit price? Why or why not? Oh, that's good. They show us the unit price right there. Well, we can see on the second one that this one's pretty easy to see. $1.32 for one should be $1.32 per each. So this one checks off. But what about this other one? So we're going to take that $4.27 And it's per each, so it should be per one pack. So we'll compare this to our 3 packs, right? So when we divide this by 3, then we get 4.27 divided by 3, 1.42. So $1.42. There were some 3s after this, but again, those just are going to make that round to 1.42. And this is out of a 1 pack. So how did that label come out for the top one? It's a little off right there, and that looks like an actual picture to me. So yeah, I'm not this is not to bash on this is not to bash on any retailers, but just again, this may be, I mean, it looks like a legitimate picture, so maybe we should be a little bit more careful. I use those all the time, in fact. So it makes me think I gotta check, man. Well, we found the actual price, so can we trust this stuff? It looks like we can't. No, because, well, it's not 168 per each. Now, there is something else about that label, though, right?
I can't really see that it says 3-pack.
Yeah, it doesn't say that it's a 3-pack, and in addition to that, it says per 100 count right there, right?
Where?
Just right here. I mean, it's so small
Oh, it's
right there, right?
There's only 85.
So yeah, it is. Oh yeah, that's
So
That's
that
good.
could be why it's charging.
Oh.
yeah, that's 85.
So then we can break it
Per
down to how
pack.
much each sheet it is, right?
Yeah. So as it turns out, I mean, maybe we could do that. The second one here shows that it also is 85 count, right? So there's the same number in each pack, but per 100 sheets. Oh, let me ask you this.
Maybe they are right then.
I'm sorry.
Maybe they are right because that's for a pack of 85.
Yeah.
And they're considering that price for a pack of 100.
Yes. So, well, let's look into that, okay? But first, before we do that, which one is the better buy? The bottom one's still better because per pack, and both of these have 85 per pack. We can still see that that second one is still the better buy. But let's see if this is accurate. Now, again, I assume that it is because this looks like a legitimate picture, but let's just check to make sure. So if there's 3 packs, I got 3 packs at 85 tissues per pack, right? So what is that? 3 times the 85, I got 255 total tissues in each pack, which it also showed us right there. Well, if I divide this by 3, I'm sorry, that's per 100, right? I apologize. Let's look at that. So this is 255 tissues, right? And the price was $4.27 because it gave us $1.68 for every 100. So this goes into more of the proportion stuff, which is what we're going to get into anyways. 255 tissues. Well, what would this be for 100 tissues? Well, again, the question is, how do we get 255 to be 100? Yeah, so let's do it for 1 tissue, okay? So I'll just show what she said. That was excellent. So I got 0. And this is what you got, right? 167.
705.
There's some change there.
Yeah.
But when we multiply this by both of these by 100 to get 100 tissues, then we get $1.67 for 1 tissue. Now again, they're going to round this up no matter what. Okay, grocery stores will do that because at the register, well, they're going to round up. Okay, so I mean we would say technically they're a little off, but it's still accurate. It's just, yeah, notice the difference there. And that's in very, very fine print. I assume that would be really, really small right there. So was their labeling accurate? It was accurate, right? The problem is that we're comparing two different things, so we got to make sure that we're comparing the same thing as well. And that's what we did to start out with, by the way. We got 142 per pack, and then up here 132 per pack. And they all had the same amount of tissues in them anyways.